In predicate logic, there are quantifiers, which I've previously mentioned. There are two of these. There's what's called the universal quantifier, and its name is highly suggestive. It quantifies universally. It says something about everything within a domain or within a universe. The existential quantifier is also, I think, indicative by its name. Existential exists. And this is given by the backwards E. And these quantifiers always go together with one variable. They don't pair with names, they go with variables. What do I mean? Well, you write it like this. Existential X, there exists an X, or universal Y, for all Y. Okay? Got it? Okay. Now, just as a funny anecdote, the universal quantifier is actually a upside down A, isn't it? And the existential is a backwards E. Why might we invoke these symbols? Well, it turns out that, whatever this was, a few hundred years ago, when people in mathematics and logic were starting to, think of new symbols to use for their work, they had to take into account other considerations. Okay, here's the consideration. If you're a logician and you're writing a new book, I mean, this is back in the 17th, 18th century. If you're writing a new book, you want to disseminate it, you need it printed on physical paper. Now, printing back then was done with primarily the printing press. Well, it depends when this was, but it's printed quite physically and mechanically. You have these metal things, and you stamp them on a book, whatever, right, individually or via printing press. Now, logicians were worried that it would get really expensive to print these books if you had to make new symbols and therefore have these printers, these professional printers, make up new metal molds or metal hardware to print. So what they did was use an A, which they already had, and then turned it upside down. That way, you wouldn't have to make up a new mold for it. Similarly, with the E, you just turn it backwards. And there you have a new character, right? So it's interesting. So, we didn't really choose these characters for any particular reason other than to save money, right? Which is, the motivation that drives, half our decisions, right? Okay. Let's talk about variables then. Quantifiers are paired with variables. So now, variables are unlike names. I've mentioned this before. Names pick out specific things. And names could pair with names and pair exclusively. Okay, yeah. So names pick out specific things, but they also pair exclusively with predicates. Okay. What I mean by that is names, A, B, whatever, Anne, Boris, they pair with predicates exclusively and nothing else. They do not pair with quantifiers. Now, variables can actually be paired with quantifiers or predicates. So let me give some examples. We have, say, for all x. I mean, you might also say bx. For all x, x is b, where b might be a predicate that says A is big. So we might read this as, I shouldn't put them in parentheses. Let's put them in quotation marks. You might read this bit as, for all x, if for all x, x is big, then you might not know what that means. But we'll gently introduce it shortly. Okay, so why might we use variables? Why is there this complexity? Well, as I've said, variables allow us to generalize to a group of things, but because we use quantifiers, we can also keep track of which predicates are applied to which objects. Of course, objects can have many predicates. Not only is Boris big, he might be boisterous, he might be a Russian or whatever. We can apply many predicates. And with these quantifiers and variables, we can make general statements about the world, which we do all the time in natural language like English. Okay. Here is an existential quantifier. I said that the name existential is highly suggestive of what it means. So what might this mean? Well, it could say something like, there exists an X. Okay. There exists an X. and X is funny, where F is funny. You're saying there exists an object in the world, and that object is funny. Okay. I think this is tantamount, or it's the same as saying if we go through all of the objects in the universe of this course, then we will find at least one thing. We will find at least one thing that is X, and that X has property F. A brief word on universes. Usually when we're doing logic, philosophy, maths, we limit the universe of this course somehow, right? We're not talking about everything in the universe. Sometimes we might do, but we might be talking about, everything in this room, everything in this domain, everything in this bucket, so on and so forth. We won't worry about specifying the universe of this course for now. Okay, it could also mean, I think, more intuitively or more simply, instead of this whole long sentence here, that there is an X such that it is F. Okay. Cool. Any questions? Okay. What about the universal quantifier? Again, its name is highly suggestive. For all x, fx. Okay, this might say something like, if we go through all the objects in the universe of this course, then every single thing within that universe will have the property f. Every single thing will be funny, right? This is a much stronger, logically stronger claim. In the previous one, we attributed being funny to at least one thing. It could be three things, could be everything. I mean, these aren't mutually exclusive. They can coexist. But the claim is different. In the previous case, they're just saying there's at least one thing. In the universal case, they're saying that all things. And, rarely are universal statements like this true, at least with just one predicate. You can't, rarely is everything funny. We either have to limit the domain, the universe of this course, or we add more predicates, Actually, adding more predicates will make it more unlikely. But I think the key here is to limit domain. Okay. This, I think, is tantamount to say more intuitively that for all things, it is such that they are F. All things are F. Okay. So here are some examples. If G is A is green, for all X, Gx is just saying all things are green. What about this? There exists a Gx. That's just saying there's at least one thing that is green. Okay? Easy peasy? Okay, how about this? What about negations? So we dealt with negations with predicates and names, but here's a negation of a quantifier. What does this mean? Well, I've given it to you here. This just says it is not the case that everything is green. Excuse me. That's just saying not all things are green, right? Okay. The negation is applying to the quantifier. So you say it is not the case that for all x, x is green, which is, of course, not all things are green. Okay, what about this? What might this be? Anybody? Type or shout it out. The negation is applying to existential. There does not exist a thing that is green, which is just a saying there's not a single thing that is green or nothing is green, right? These are all logically equivalent. And in fact, because we've come to predicate logic now, where there's a lot more complexity, there's going to be a lot more logically equivalent statements. And when it comes to symbolization, the key here, I think, is just working with one that comes most naturally. You can sometimes give very complex symbolizations for an English language sentence, and maybe your mind works that way. But chances are there'll be one that's more natural to you, and that one will be quite intuitive, simple, elegant. Okay. Here's what I want to emphasize. The negation can actually occur in two different spots. It occurred before the quantifier and in between the quantifier and the predicate. It's more accurate to say that in the second case, the negations are applying before the predicate. Both of these are well-formed formulae. Okay? They're both acceptable, but they mean different things. Okay. Previously, I said that the negation can't go between the predicate and the variable or the name, like this. This is nonsensical. It doesn't mean anything. Whereas these are sensical. They mean something. However, they mean different things. Let's think about it. The negation here is applying to the quantifier. And from the previous example, or the previous slide, you should know that it says something like, it is not the case that for all x, gx. So it's not the case that everything is green. Okay. What about this? Let's read it out. For all x, it is not the case that it is green. Sorry, I misspoke. Okay. This, I think, is better captured by the English sentence. For all x, it is the case that it is not green. Okay, let me try that again. This says it is not the case that for all x, x is green. This says for all x, it is the case that it is not green. Okay. The first one says not all things are green, right? But this says all things are not green. Does everybody see the difference here? This says there exists something, basically, that is not green. You know, there might be something that's red. Say we have a bucket, and, you know, a lot of things here, a lot of these marbles here are green. But when you say the sentence, you're saying maybe there's something that's red, okay? Okay. In the lower example, when you say all things are not green, what you're saying is, look, there might be a bunch of marbles and they're all different colors, but what you know is the case is that there's nothing that's green. You can't put a green thing here, and that's wrong. That's difference. Okay. Any questions? Right? I mean, this is, you know, your 5-year-olds can get this. But sometimes, I mean, even for myself, once it's in predicate logic, it takes me a while to think about it. Okay. There's also a bit more complexity here. Bear with me. So there are logically equivalent sentences. This, it's not the case that for all x, gx is actually logically equivalent to this. Right? Let me just bring my annotations back. Okay. This is logically equivalent to this. Why? Because this says there exists something that is exactly what you're saying. When you say not all things are green, you're saying in the bucket, there is something that is not green. There exists something that is not green. Okay. What about this? Well, I hope you can read under that. This says for all x, not gx is equivalent to there does not exist a gx. So you're saying in this bucket, there's not a thing that is green. So exactly where you cross out the green. So there are logically equivalent sentences, even if they're using different quantifiers. So in fact, any sentence can be captured by the universal or existential. And one will come more naturally to you. But they can be captured by either. Okay? Okay, here's a reference sheet. I'll leave you to it. We'll talk more about quantifying negation in the future. There is a move. There is a rule that lets you translate from the top to the bottom and vice versa, actually. And we use it all the time in derivations. But I want you to know now that there are indeed some logically equivalent sentences that employ the other quantifier. Okay, here's an exercise. Please do this. I'll give you a minute and a half. If you're done, write done. Okay? See you in a bit. Okay, 50 more seconds. This is actually kind of straightforward. Okay, so I think here the test is just your familiarity with names versus variables, and maybe some quantifiers. Okay, so doesn't matter if you haven't finished. Let's take a look together. Aristotle is good. Let me just do these for you in the interest of time. We say G. Oops, that color is atrocious for legibility. Or use blue. G A, big G, little a. Aristotle is good. Okay, that looks correct to me. All things are good. What about this? For all x, gx, right? Something is good. There exists something that is good. That's the same thing. So existential x, gx. Nothing is good. Okay, what about this? Nothing is good. There are actually two natural ways. Nothing is good. There does not exist something that is good. Or, of course, you can say, for all x, it is not good, right? Either one is fine. Did some of you use this one? Yes, no? Did some of you use the universal? Yes, no? Yeah, okay. Takes you a while to answer. Okay, and some of you use the existential, right? If yes, then our minds work in different ways, and that's perfectly normal. I mean, some of you could have gone really well, maybe not with this one, but I remember from last year, some people just give me crazy symbolizations. That's fine, but please don't do it on purpose. It makes marking really, really, really hard. You know, something that could have just been one take takes me 15 minutes to think through, to try to write it out and stuff. Okay. It's actually a demonstration that you don't really understand it, but somehow you got it. Okay. Okay, let's move on. Not all things are good. What about this? Not all things are good. It's this. Yeah, there might be something that's bad, or something that's not good. And again, that's saying this. These are equivalent. Okay.